Welcome everyone. We are glad to start our new project for artificial intelligence, which will be able to predict and detect credit card frauds happening in the financial industry. Our today's objective is to get started with project introduction. We are going to understand how we are going to create a business plan before we start a product. And once we are done with creation of a business plan, we are going to identify project goals and how we can achieve them. So that's what is going to be today's session. Finally, we are going to explore the data sets which will be required, the open data sets which are available and data sets available from different banks who actually issue credit cards. Okay. So now this is what is going to be our objective for this session. I'm your project manager for this session. My name is Devanshu Shukla, and I'll be taking you through this project step by step so that you all will be able to build up an end-to-end product for credit card industry. Now, one thing you guys need to understand initially that credit cards are very important today. And there are a lot of banks available. There are a lot of financial institutions available which release their credit cards. And every credit card has a limit value. So it could be like 10,000, 20,000, it could be 10 lakhs, 20 lakhs, depending on the profile or the CIBIL score of a user. Now, what happens is, in case if mistakenly any fraud user is given a credit card and he swipes out the credit card and he extracts all the amount, the bank is going to be in loss. So one of the biggest problems these banks face when they issue a credit card to a user who would be a fake, who would be a fraud. So banks are really interested to buy those solutions which can help them identify if a person is a fraud. So financial applications are available. There are a lot of applications available today wherein quick loans are being allotted to people just depending on their PAN card and their CIBIL score. So if banks have to protect themselves against these credit card frauds, so they need certain solutions. And artificial intelligence technology is a very nice technology which can detect anomalies, which can detect patterns, and using these patterns, we can predict the fraud behavior. And once we are able to predict the fraud behavior, we will be able to predict that a user should be allotted a credit card or not. So one such company, American Express, is a financial express company. We have a person on our team, Mr. Sumit Dhama, who is interested to work out on solutions like how to diagnose credit card fraud activities and how to protect companies like American Express from issuing cards which are issued to some frauds or somewhat like that. So we are going to identify solutions to these problems. And a lot of things are happening in the industry which we are going to explore. So objective of today's session would be to get introduced with the project. So let's go ahead. So here on your members card, here is a research paper which we are referring. This is a base paper which we will use for our research. And then we are going to come up with the latest solutions which can help us predict credit card frauds. So I'm going to take you to this paper. So this paper is written by John Adebayo and Samuel. These guys are from Nigeria, Department of Computer Science and Technology from Federal University of Technology. They have done a comparative analysis on credit card fraud detection using machine learning techniques. Now, as you all know, machine learning has reached to a very high level. We have deep learning, reinforcement learning, and we have optimal solutions to perform credit card fraud detection and a lot of things we do have. So now what we are going to do, we are going to understand what this research paper has to say. So whenever we start working on a product, we take a base research. In a base research, my personal opinion is to initially get started with the conclusion. And if you like the conclusion, you can go back to the experimental analysis section and you can identify what all techniques have been implemented. So personally, when I start working on a project, I refer to a research paper wherein I would like to get an idea about what all solutions researchers have identified. And then I would like to come up with a product which users can use. Because as you all know, there are a number of users in the world. You are a solution maker. Once you make a solution, you have to make that solution reach to the people, those who need it. So once you're going to share your solution with the people are going to get solutions to their problem and they are going to return a value back to you. Now, this value could be in terms of wealth, this value could be in terms of prosperity, which you guys are going to get. So, being a computer engineer, being working on a credit card product, your audience is a business to business audience, which could be a bank, which could be a financial institution who will be buying your product because they deal with millions and billions of rupees per day. Hence, identification of frauds is very important for them, and this could be a very positive solution for them, which can protect their company from getting used to with the frauds. So you are going to get a lot of value in return if you make products like this. So now let's quickly see what this paper has to say. So this paper investigates the comparative performance of multiple algorithms. There are three algorithms they have compared: naive Bayes, k-nearest neighbor, and logistic regression. So this was a binary classification for imbalanced credit card fraud data, which they have explored. So now in this, what they have done, they have taken three classification algorithms. The classification algorithms are naive Bayes, k-nearest neighbor, and logistic regression. And they have been trained on real life of a credit card transaction data. Okay. So from where you're going to get a real life credit card transaction data? From an institution, from a company who deals with real-time credit card transactions. And you guys won't believe, there are billions of transactions happening with a credit card per minute or per second. So it's a very nice, very big challenge which you guys need to take up and which you need to solve with artificial intelligence technology. But you guys need to understand, you've got a research, you've got a little idea about how people have implemented it. But now what we are going to do is, we are going to identify the optimal solution which can detect credit card frauds, and we have to make a business plan. Because in our case, in credit card fraud detection, the consumer is a business to business company. He would be a stakeholder. So what you guys need to do, you guys need to prepare a proper plan. You need to understand each and every aspect of how a business plan is created. And then you have to show that business plan to the stakeholder like American Express. And if they got the hit, if they got to know that, yes, you have the right solution for the problem, then they will definitely buy your product. Once they buy your product, you're going to get value in return. And this value can be treated as money. So we are going to have all these things in our project development program. Now, the second information you have is a highly imbalanced data set is sampled in a hybrid approach where positive class is oversampled and the negative class was undersampled. Hence, two sets have been achieved with the data distribution with this paper. So we may be doing our own techniques in order to clean the data, in order to pre-process it, in order to perform various other techniques which are possible. And the performance of the three classifiers are examined on the two sets of data distribution on certain metrics. So the metrics computed were accuracy, sensitivity, specificity, precision, balanced classification rate, and Matthews correlation coefficient matrix. Okay. So here, as you guys can see, performance of classifier varies across different evaluation metrics. Results from experiment shows that K-NN shows significant performance for all metrics evaluated except for the accuracy in 10 raised to 90 data distribution. This study shows the effect of hybrid sampling on the performance of binary classification of imbalanced data. Expected future areas of research could be examining meta classifiers and meta learning approaches in handling highly imbalanced credit card fraud data. So what we need to do, we need to work out on this. We are going to examine multi-classifiers and we are going to work on meta learning approaches in order to deal with highly imbalanced credit card data. And we are going to come up with a solution which we are going to propose to the credit card companies. So this is one big thing which you guys need to implement in. Now, I would like to take you to the experimental analysis section, wherein you can see that values like, this is a very important graph which you guys can quickly observe. So you can see that according to this research paper, you have naive Bayes algorithm, which is 97% accurate. But in all other aspects, we believe in specificity also, Naive Bayes is good. In sensitivity, KNN is good. Logistic regression is kind of pretty good in under the undersampled data. So you all can see that you have got logistic regression was working a little well with respect to other algorithms. So it was 97.96 balanced classification rate, but it could be less when the data was distributed. Okay. So now when the data was distributed for specificity, for precision, for sensitivity, this was working pretty well. Only the accuracy of Naive Bayes was better, but sensitivity, specificity, and precision was much better when it comes to KNN. But we are going to explore n number of algorithms in order to identify how we are going to perform credit card fraud detection. Okay. So this is the whole idea of the project which you're going to do. You're going to make a product. You're going to have a very nice web application which will be working, wherein it could be a web service wherein as soon as somebody applies for a credit card in the credit card company, the credit card company is going to send you a request. You're going to quickly validate whether this transaction should be done or whether this card should be issued or not. And you're going to send a true or false response back to the company. So depending on your response, they will issue or they will allow the transaction for the user or they will deny it, depending on how strong your product is. So that's what we are going to do. So now when it comes to this, the first thing which we are going to do today is we are going to create a business plan for credit card fraud detection. Okay. Before you go to credit card fraud detection, we'll quickly explore what data sets they have explored. And I'm going to send you a couple of data sets which you will be using. So we can quickly search for a data set here. So now you can see that I have searched for the data set which has been used in the reference. So here a few imbalanced data sets, a lot of names have been used here. And they don't have any such specified standard data. Okay, they have used it. So this is the information. The data set is used from ULB machine learning group and the description is found in 32. Okay, so you can quickly go to this reference number 32 and you can get the data from ULB machine learning group. So we are going to quickly observe what that is. Otherwise, what you can do is you can quickly get that from a Datathon data. So here it is. I think they have taken it somewhere from here, the performance of Naive Bayes on this in 34. So it could be better. We can quickly search for the data set here, ULB machine learning group, credit card data. Okay, so we'll quickly search what do we have here. So yes, we have something like here, ULB machine learning group. ULB machine learning group, as soon as the site loads up, we'll quickly check back if they have any direct download link for the data for initial analysis. So you can see that they have a lot of information. They are doing certain projects on various things like defeat fraud, right analysis, Brussels analysis, and a lot of things are being happening here. I need to quickly check back if they allow this data set or not here. So no, I cannot see any data set here. So what I'll do is I'll quickly go to Kaggle. So Kaggle provides credit card data set, and here there is a complete list of credit card fraud detection data sets available here. So I'm going to share that on your project cards. So you can take up credit card data set from here, from this link here. You all can quickly download that. You can open that. I am also going to share that with all of you on chat. So here the data set is sent on chat. So guys, is my voice audible to all of you? Are you all able to understand? If you have any questions, you can shoot your questions on chat. Great. So now, so here is a list of data sets which we have for credit cards. Now here, so you have different kernels, you have the credit card.csv file where some information is available about the time. There are certain variables which you need to identify how these variables are correlated to each other. Okay, so that's what you can do. You can quickly get started with one data set over here As well as out of this, I would also like you all to quickly get back to certain information about credit cards from Twitter also. Okay, the unstructured information. So now what am I going to do? I'm going to give you a quick link to the downloads. So I've clicked on download here. This is a 1.44 MB file, which you are going to use. You can sign up to Kaggle.com, where you can find out the best data sets in order to get started with analysis. So I'm going to sign in with Google. Let me just quickly sign into this. So I'm going to authenticate via Google from my account. So once I got authenticated, I'm going to get credit card fraud detection web page open again, and I will be able to download the data now. So once I click over here, so you can see that I've got this download link loaded. I'm going to copy this link. Okay, I'm going to share that link on chat. If you guys are able to download it, you all can use it from here. I've shared that with you. And I would also like to share the data set download here. Okay. In case if it works, you can download that from here. Otherwise, you can directly go to the library, go to this page, and you will be able to download that. So this is machine learning group ULB, which actually contains anonymized credit card transactions labeled as fraudulent or genuine. Okay. So there are multiple transactions, and these transactions has two types of category. Hence, you are going to have a classification algorithm. So one category is a genuine transaction. Another category is a fraudulent transaction. And depending on that, you're going to identify a lot of patterns depending on credit card data and how it is happening. Okay. For confidentiality purpose, you have the real data, but the transactions are anonymized so that you won't know which column is what. Okay. The final objective we do have is we need to have a model which is highly accurate. That's what we guys need to do. Okay. So once we guys are done with the download, we are going to load that data, and we are going to have that on our collaboratory, where we are going to get started with the code. So now what you can do is, let's go to collab.research.google.com, where we are going to get started with the project. So once this is loaded, we'll do have a check. I'm going to get started with a new Python 3 notebook on collab.research.google.com. This is a Jupyter notebook. As you all know, you all are comfortable with Python and machine learning, I believe. You all have done a project, house price prediction system. Now this is your second project, wherein you will quickly proceed with classification algorithms and further different things, which will actually sort out the fraud problems. Okay. Now, so this is going to be our credit card fraud detection project. Okay. And let us just quickly connect. We are going to connect to Google Compute Engine backend. We're going to observe once the data set is downloaded, we are going to upload that either on the server, or else I'm going to do that on my collab. So instead of this, I would like to handle my data on a cloud server so that you all will be able to access that. So what am I just doing is I'm opening my cloud server, which is an AWS cloud server. I'm going to load it. You guys don't need to do it. You guys will be directly able to access the data from this link. I will keep the data on my cloud server. So I'll go to where World Wide Web HTML directory. And here I'm going to download the data set. Let me just quickly check back. So I'm going to paste the code here. I'm going to check if that gets downloaded. So yes, I think that gets downloaded. I've got a 65.9 MB file downloaded here on my server. And I'm going to quickly do a list. Okay, so just need to check. Okay, I need to rename that archive.zip. So I'm going to move archive.zip into archive.zip file. Now I'm going to ls. So archive.zip is loaded here. Now I'm going to call unzip archive, or else I'm move archive.zip into credit card.zip. Let's call this credit card data.zip. Okay. And now I'm going to unzip credit card data.zip. So once I unzip, I've got the CSV file extracted. Okay. So under this directory, okay, I've got that outside here. I believe credit card.csv. So I'm sharing a link with all of you. Close that. And here, just to let you all know where you can access this data, you all will be able to access this data on this IP address. I'm sharing that with all of you on chat, as well as I'm sharing that on your project cards. So the server data set on server, and that's available over here. Okay, you can access this IP address. You can also call it as something like HTTP, and you can access that. And here on this IP address, you can see that you're going to have credit card.csv file. Right click, copy credit card.csv file, and you guys can get started with the analysis. Okay, so that's the URL which we all will be using in. So now we come to credit card fraud detection project. We are connected to Google Compute Engine backend. First, we're going to get started with data gathering for analysis. Data gathering. Okay. Now, once you start data gathering, what you're going to do? You're going to import pandas as PD. That was your, this is your data handling library, the 2-dimensional size mutable data structure. Now, once you run this, you're going to use pd.read, the comma separated values file, and you're going to pass the URL of the data, and this is going to be your credit data. Okay, and now you can quickly check back, print the columns which are available in the credit data. We're going to call it as credit data.columns. And finally, I'm going to quickly show you the data, credit underscore data. So once we run that, since it's a big file, it is approximately 144 MB. So you may be having a lot of data in this. So let's quickly run that. You're going to get the file downloaded. And once you get the file downloaded, it could be a better option. You can also download it using wget command on the server so that you can use it again if the runtime is not recycled. Okay, now you can see that. So we have got a lot of transactions. So approximately, you guys have these many transactions. 284,000 transactions data is there, and which is distributed into 31 columns. So that's like a good data available for you all to perform the analysis. Okay, and all this data is in numbers. So you can see that finally we have an amount, we have time, and we have a class. Okay, so let's say we are going to perform this transaction. Let's have a look. What all properties we have, what all behavior we have on the financial data, and how you are going to extract the information. So are you guys done till here? Just confirm me on chat if you guys are done till here. Okay, now, so once you guys have got the information till here, now what am I going to do? I'm going to get the credit data and I'm going to fetch some information. So I'm going to pass a list of columns. So I'm going to fetch time, I'm going to fetch the amount, and I'm going to fetch the class. Okay. So let's just quickly do that. Let's have a look what all we have. So we have two classes. Okay. Let us just quickly check the unique values of the classes. I have credit card, I have credit data. I'm going to get the class and I would like to call a unique function on it. Just to quickly check back, we have two cases, 0 and 1. Okay. Now you need to check what value is 0 and what value is 1. So you can go to the context and you can identify what information we have here. So now it is important credit companies are able to recognize fraudulent credit card transactions so that customers are not charged for items that they did not purchase. Okay. And with respect to the content here, you can quickly go back to discussions, wherein you can identify a lot of discussions are happening over here, which you can see, as well as you have different kernels, different public repositories, which people have coded in Python in order to get the anomaly detection and get a lot of codes for dealing with imbalanced data sets. So a lot of people have written multiple codes here, okay, with different algorithms, with TensorFlow, with anomaly detection, with skewed data. So these are all the scripts which are already available with the developer's code. Okay. So now what you guys can do, you can have a lot of information here. So here is one example, a person who has done on KNN and naive bias. You can explore that, or else you can write your own code. Okay. So approximately 2,200 codes are already available on credit card fraud detection. But our requirement is to get the best out of it. Okay. So we are going to explore that with various different options. So we are here. Okay. So 0 is going to be the fraudulent, and 1 is going to be your genuine transaction. So 0 is fraud transaction, and 1 is going to be your genuine transaction. Okay. So now, so what we are going to do, we are going to quickly have a graph created here. Okay. Let's check the correlations, or let's plot a graph between, you're going to plot a graph between your amount and the fraud transactions and the class. Okay. Between amount and frauds. Okay. So now we are going to see what range of frauds have been done. So we are going to put that on axis, but since there are only two classes, so let us see what kind of graph we are going to get. If we put it on X, we are going to get two vertical lines. Okay. So let's see how we are going to get that. So we're going to import matplotlib.pyplot as PLT. Okay. And you're going to make PLT dot, let's say you can make a scatter plot. And in the scatter plot, you have to pass the x-axis and y-axis. So you have credit data, and you're going to pass your, you can keep your amount on y-axis, and you can keep your class, which is genuine or fraud, on x-axis. Okay. So once we do that, let's just quickly execute that and see what kind of plot we get. So we got a plot somewhat like this. Okay. So generally you can see, okay, here are certain transactions which happened here. So here you can see that these are transactions which are identified as 1, and these are the transactions which are identified as zeros. Okay. So I would again quickly check back what is 0 and what is 1, so that we will be clear with this specific data, because I have also not used which value is 1 and which value is 0. I'm going to explore it. Okay. Now let's see. 1 was fraud and 0 was non-fraud. Okay, fine. So guys, as per the research paper, the paper for reference, you can refer the research paper and you can identify zero transaction was the genuine transaction, and one, the transactions which are known as one, these are the fraudulent transactions. Okay, here. So now you can see that. So you have got the fraud transactions available over here. Let me just like a spelling mistake. I've got fraud transactions. Okay. So now you can see a behavior between genuine and fraud transactions. And the initial behavior says fraud transactions ranges up to a value of, let's say, from 0 to 10,000 only. And there are no big fraud transactions happening. Okay. So one thing you can see that majorly fraud transactions are happening for very low values, from $0 to $1,000 approximately. Okay, $0 to $1,000 or $2,500. So this is one pattern which you guys have got to know. Now what you are going to do? Let us just quickly go back to the top, and we are going to label this graph a little. Go plot.xlabel. And you're going to define on x-axis, you are going to have the amount. Okay. So I'm going to have, sorry, yes, I would like to have the amount on x-axis. Or it could be much better if we can put the class on x-axis and the amount on y-axis. Okay. So here on xlabel, I'm going to set the class or genuine or fraud transactions. Okay. I will also let you know how you can quickly keep the names of the labels at specific position. One should be treated as genuine, zero should be, one should be treated as fraud, zero should be treated as genuine. So I'm going to tell you that in the upcoming session, because today we have a little less time. So we will be doing that up to Y label only. Now here, so you're going to get genuine or fraud transactions. On Y label, you're going to have something like amount. Okay. Transaction amount, let's call it as transaction amount. And finally, you're going to have the title. You're going to set title, plt.title, and this is going to be transaction amount versus fraud. Okay. So now, so once you do that, you're going to get a graph ready. Okay. So you have got transactions amount versus fraud data. You have got transaction amount. You can quickly put that transaction amount somewhat like this in USD, US dollars. Okay. And you can have genuine and that value as well. So you're going to get transaction amount in US dollar, and you're going to get genuine or fraud transactions. So you can see that your genuine transactions ranges for all the values. Okay. But the fraud transactions are very small, for a very small value up to $2,000 or $2,500. So this is one pattern which we got to know. Okay. Now, once you are done with this pattern, if you want to use that image in the presentation, you can go to save image as, and you can download that image. Okay. So let's say transactions pattern 1. So you guys can quickly download that image and you can use it for your stakeholder presentations. Okay. Now, apart from that, let's go back to the next one. So now you can see that we have to, there could be some problem that why only low level values are being done. It could be possible that high value transactions could also be fraud transactions, but there may be some security involved to avoid certain situations. So we need to identify that. So now what we're going to do, we're going to plot a correlations matrix. Which was referred to us in the research paper, that you have to plot a correlations matrix. So we are going to get credit card, and we are going to call correlations functions on it. Okay. So once you call correlations function, you're going to get Okay, sorry. Credit data dot correlation. This is credit data, and you're going to grab correlations. So what correlations is going to give you? Correlations is going to give you a cross matrix, okay, wherein you are going to compare all your 34 columns and you're going to identify the influencers which may be influencing your amount, which may be influencing your fraud transactions. Okay, so now what am I going to do? So instead of time, you can have another values like V1, V2, V3. You can have a correlation matrix using which you can identify what all factors are highly influencing the amount. So, or the class. So what we are going to do, we are going to have a, you're going to have a matrix, correlation matrix. Okay. So create a correlation matrix so that you can quickly observe the variables with a correlation matrix kind of a plot with a color plot that would be easy for all of us to observe. So we can import stats models.api as SM, and within SM we have a library known as graphics. First we'll import SM stats model.api, then we are going to use SM. It has a graphics library. Then it has a function known as plot correlation. Within this plot correlation, we are going to pass the value of credit card dot correlation so that you're going to get, sorry, this is credit data dot correlation. Credit data dot correlation. And you're going to pass in the value of the columns, and this could be credit underscore data dot columns. Okay. So once you run that, now you're going to get a plot. Let me just quickly check. Okay, this is going to be, I believe, column. Unexpected argument column. It may be index or maybe, so I'll check that, what that variable is. Okay, so what we'll do, first of all, let's just quickly plot that, and then I'm going to check the help and I'm going to run that. So once you plot a correlation matrix, you're going to get a correlation matrix somewhat like that. Okay, so now you can quickly observe for the values which are coming in here. You have got two plots here, wherein mostly other variables are genuine. Now we need to check which column is highly correlated. So let me just quickly execute a function, a help on this, so that I'll get to know the name of the columns which we have to pass. Okay, so the parameter which you need to pass is X names. Okay, X names is the names of the columns. These will be appear on this color grid so that you will be able to observe. So now what am I going to do? Let me just pass this variable as X names, and I'm going to pass credit underscore data. Okay, and this is going to be the columns which I'm going to pass. So once you run this graph now, so you're going to get these factors. Okay, so we can set these initially so that you will be able to grab that clearly. So on the left hand side, now you all can observe you have got the columns represented over here, and if I need to check how many are influencing, okay, so the influencers with respect to the class, you can see that there are common influencers. Okay, so how many influencers are there? The influence is up to a range of from here, somewhere here the color matrix goes from here. So if you observe, the color matrix goes from here up till here. Okay, so there may be many positive or negative correlations value, so that we are going to observe as soon as we progress further. Okay, so since we have reached the time limit of our today's meeting, we are already reached till 7:30 p.m. So we are going to continue our meeting from here on the next meeting date, which is Tuesday. So let me quickly tell you the curriculum, what we will be having in the next date. Before I complete this session, I would like to share this link with all of you. I hope you all already have the information about how things has to be done with structured machine learning. So the data set is there, and here I have share the script code also with all of you. Okay, script code for today's session. So you guys will be able to access the script code here for practice, and so you can do that. And now I'll take you to when next we are meeting. So we're done with our today's meeting today. Now the next meeting will be on 8th of October. Okay. So on 8th of October, we have our meeting scheduled from 6:30 p.m. to 7:30 p.m. Before that, I'm going to share a lot of resources on your project card. Kindly go through with the resources. These resources will be relevant to your project, what we are going to perform in future, so that if you guys get time on weekdays, you should be able to implement the code and you should be able to ready up till the next meeting. As well as final, what you all need to do, you need to come up with your presentations on the next meeting date, because we are going to have the team presentations, and followed by we are going to work out on this product. We are going to make a web service and a web application wherein people can quickly test whether a transaction is a fraud transaction. Okay. So thank you so much everyone for being available. Thank you so much for watching this video.